Alright, this is the first of the Northwest Allen County Schools Earth and Life Science Benchmark Test for the 8th grade. There's actually three parts to this podcast. We'll go ahead and get started first with Chapter 5. Chapter 5 starts out with the water cycle. You need to know the processes that work together in the water cycle and how energy from the sun factors into this. As you can see in this diagram, we'll start out with evaporation when the water leaves the surface of the ocean or the surface of a lake or any standing water and moves into condensation. After it becomes condensation, when it becomes condensation, it actually changes from the gaseous state to the liquid state. It eventually gets into large enough droplets that it falls then as precipitation to the surface and continues on as rainoff or runoff and transpiration. And it will continue through that cycle. Now, of course, driving the whole thing is the energy from the sun that helps to provide all the necessary energy to continue the cycle forward. Now, the next thing you know is how the water cycle affects the total amount of water on the earth. And it is always the same. There's always the exact same amount of water on the surface of the earth. The next concept is what a watershed is. This is a land area that supplies water to a river system. For example, we are part of the Wabash watershed, and you can see here when you look at all the other rivers or tributaries that feed into the Wabash River, that whole area becomes part of the watershed. And of course, there's a divide then that goes along with each one of those, or along the boundary here, that defines that that's part, or that's where the water will go either towards one watershed versus the other. The next topic is looking at how ocean currents can affect the climate. So ocean currents can both warm and cool the air above them. So for example, a warm current will generate a warm air above it, whereas a cool current will generate cool air above it. And as the air temperatures change, the climate changes because it causes precipitation, and then of course temperature changes at the same time. Also remember that this can cause some other more larger wind currents to develop along with that. The next topic is knowing the cause of ocean currents that flow along the ocean floor. This is due to differences in density. Different densities cause the water to move differently. Remember, the density can or it increases as you go deeper because there's more pressure. We also see the salinity changes, and more salt in the water means that the density is a little bit higher. And you can remember back from we didn't do one this year, but I'm sure you've done one in probably elementary school where you did the density column looking at oil and water. The more dense something is, the deeper it goes, and those density changes cause them to move. So you can also then think about how wind works. It's actually the exact same concept, just it's using air as the fluid instead of water. The next topic on the list is knowing how water can be considered a scarce resource. Remember, there is very little water that's actually fresh water on the surface of the earth. It's mainly salt water, and therefore we can't consume it. You can see in this diagram on the right hand side, salt water in oceans and salt lakes makes up about 97% of all the water on earth. The remaining 3% is the fresh water that's usable. About 0.04% is found as water vapor, about 70% is ice, 30% groundwater, and it's way underground, not usable, and then 0.26% is in lakes and rivers. If we were actually take 1,000 milliliters of, or 1 liter or half of a 2-liter bottle and divide it out, it'd be about 1 or 2 drops of that are actual water that is accessible by humans without too much of a struggle. The next one is know the main effects of an El Nino or La Nina weather pattern. Remember, the El Nino is warm water in the Pacific, causes severe conditions in North America. La Nina, on the other hand, is caused by cold water in the Pacific, and it actually gives us colder than normal winters and allows there to be more precipitation in the Pacific Northwest. The next topic is knowing what causes deep ocean currents to curve, and this actually has the same effect on the wind belts as well, and it's called the Coriolis effect. Global winds and ocean currents both curve because of the Earth's rotation. And we can see an example of that if you recall back. We took the globe and put a piece of tape on the equator and then at the North Pole, and then tried to spin and move your finger from top or from the equator to the outside edge, and you found that every time you tried to do that you were never able to line up with the tape because the globe moved from underneath you because of the rotation of the earth. That wraps up chapter 5, so we'll now move on to chapter 6. Chapter 6 starts out looking at the ratios of gases found in the air we breathe. 75 or 78%, or roughly 3/4 of the air, is made up of nitrogen. 21% is oxygen, 1% argon, and then every other little bit of gas falls into the other category that's just a little bit more than 0.1%. The next one is knowing the layers of the atmosphere and what occurs in each. We'll first take a look at the troposphere and then the stratosphere. The troposphere is the one where the weather occurs. Then we have the stratosphere above that. Above that is then the mesosphere, and then finally the thermosphere. Remember, the thermosphere is what extends into outer space. Now, the one thing to make sure you understand about this then is about how we know these different layers exist, or how we define when those different layers exist. If you recall back in class, we had a range for each one of these that they could fall inside of, and it all comes down to this temperature graph that we're looking at now. And what we saw is that every time the temperature graph changed directions, or we hit a minimum or a maximum, we had a new layer. And that's actually how scientists figure out that new layers occur, is based on the temperatures of the layers and how it goes up and down as they go higher in the atmosphere. The next one is knowing the difference between convection, conduction, and radiation. These are three forms of heat transfer. Convection is the transfer of heat by the movement of fluids, and this is actually the main way that heat is transferred in the atmosphere. It's actually where the heat goes more in a circular pattern. We looked at the baby powder above the hot plate and saw the convection currents occur there. Conduction is the transfer of heat between two substances that are in direct contact, so they're actually touching. You can think of this as when you try to make popcorn on the stove. The pan is in direct contact with the heating element, and so therefore it's experiencing conduction. And then finally, there's radiation. And this is the transfer of energy by electromagnetic waves. The cool part about that, it does not require anything to travel through. This is actually how sunlight is able to reach the surface of the earth, is because it can go through the empty space of outer space and travels very easily. Conduction and convection both require a medium or some kind of a substance for it to be in. Convection for the fluid or the substance to move. Conduction, they actually have to be touching. Luckily, we're not touching the sun, so we instead use radiation. The next topic is knowing what drives the motions in the atmospheric system of Earth. And it's important to know that energy from the sun is what drives the motion of the atmosphere. It's all driven by the idea of heat transfer and that convection and conduction currents that occur. And if we don't have the heat transfer or the heat coming from the sun via radiation warming the surface, we can't get those convection currents to begin. The next topic going along with the atmosphere is knowing what causes air pressure. And you can see this picture here of the air column. You can imagine an air column extending up above you for several miles, and it does in fact extend up above you for several miles and keeps pushing down on you. Now remember, it's being you're having equal pressure from all sides, so therefore you can't tell that you're being crushed by about 35 pounds per square inch, but it is constantly pushing on you at all times. And that is actually caused by the weight or the mass combined with the force of gravity of all the air extending to outer space. The next one is looking at the idea of what causes winds, and this all has to do again with the idea of air pressure. Now remember, air pressure is the force of those objects, or force of a gas pressing on something, and of course if you're talking about the force of a gas and you have more of the gas there, the density also goes up. And so we always find is that it always goes from high pressure to low pressure, or high density to low density, like we saw with ocean currents. And we can take a look here at the idea of a land breeze and a sea breeze. And you can see in the top, for looking at the sea breeze, we have the cool air from above the water flowing over the warm air, or flowing over the warm land. And the reason why the air is able to move in that direction is because the sunlight is warming the surface of the land up and causing the warm air to then rise up because of convection currents, and it wants to go up because it has a lower density, and it continues this around. Of course, at night we see the opposite process because the water cools down a little bit more slowly. The next one is looking at the statistics of the light blocked versus filtered by our atmosphere. And this is a diagram that was inside your textbook. And that you can see that about 50% is absorbed by the surface of the earth, and about the other 50% is radiated back in some form. Either it's being reflected just straight by the clouds, or it's being reflected by the surface of the Earth. About 20% is actually absorbed by stuff in the atmosphere as well, such as the greenhouse gases that are found there. This actually wraps up part one of the Northwest Allen County Schools Earth and Life Science benchmark test for the 8th grade. And you can join on the second part of this podcast for the next few chapters.